This is a problem on projectile motion. In the chapter of dynamics, you will find this topic. You have already studied projectile motion, I know. You know that when a particle is thrown with an angle with a horizontal, not vertically in the upward direction, but it is less than 90 degree. So the particle is thrown in the upward direction. The velocity, initial velocity, makes an angle of theta with the horizontal. And in that case, you have found total time of flight, then range, then maximum range, like this. Then maximum height attained by the particle. All these things you have found out. Now, in this problem, the stone is not thrown from the plain land, which reaches again to plain land. Here, the stone is thrown from the top of a tower. Say, this is the top of the tower. The stone is thrown from the top of the tower, and then the stone reaches to the ground. So here, in this case, you have to find out maximum range. You know that when the stone is thrown from the ground, again it reaches to the ground, means at the same horizontal level we are talking about. Okay. So in that case, you know that range will be maximum. Range is maximum when theta is 45 degree. But for this problem, when the stone is thrown from the top of a tower, but ultimately the stone reaches to the ground, in that case, the range is not maximum for the angle theta is equal to 45 degree. It will be somewhat something else. So how will you find out those things? That range, how will you find out? That is the question. So first, let us analyze a problem on the simple problem where the stone was thrown from the ground and it reaches again to the ground. You know the equations, three equations are available. S is equal to ut plus half ft square, v is equal to u plus ft, and v square is equal to u square plus 2fs. All these three equations are available to solve such problems. So say we are talking about, we want to get the total time of flight first. Total time of flight. So we will start from the equation S is equal to ut plus half ft square. F is acceleration, half ft square. So here, instead of writing S, we want to write h for height, because it is vertical motion, okay? H for the height. So h is equal to ut plus half gt square. Here acceleration will be due to gravity only. So here, instead of writing F, we should write g. So h is equal to ut plus half gt square. This is the basic equation, and using this equation we will solve our problem. So the stone was thrown from the ground and it reaches ultimately again to the ground. So what is the horizontal distance traveled by the particle? Not horizontal distance, the vertical distance traveled by the particle. Initially, the vertical distance was 0 because it was on the ground. Again, it reaches to the ground. It means here the stone reaches to the ground. Then again, the vertical distance becomes 0. So initially it was 0, finally it becomes again 0. Therefore, total vertical distance traveled by vertical displacement of the particle is 0. So using this equation, h is equal to ut plus half gt square. So in place of h, we should write 0. Means replace h by 0. And then that ut part, in the right hand side, ut is there. that u should be replaced by what? U sine theta, the vertical component of the velocity. Velocity was u and it makes an angle of theta with the horizontal. Therefore, horizontal component of velocity is u cos theta, vertical component is u sine theta. So ut, that part will be replaced by u sine theta into t. And then comes half gt square, that part. So here, since motion in the upward direction, the particle is moving in the upward direction and acceleration due to gravity is in the downward direction, so they are opposite to each other. Therefore, instead of half plus half gt square, we should write minus half gt square. So we will do the same thing, minus half gt square, and solving this equation, you will get t is equal to 0 and 2u sine theta by g. Two answers you will get. First 0 and then 2 into u into sine theta by g. Okay, so what is the explanation for two answers? T is equal to 0 when, because we have used here zero displacement. So when the particle was on the ground initially, that time also displacement was 0. So for that thing, the answer time t is 0, that is valid. And the second, when it moves in the upward direction, then again comes to the ground, comes back to the ground, then the answer for time is equal to 2u sine theta by g. Okay. Now, what is the range? Range is equal to the constant velocity u cos theta. U cos theta, this velocity does not change because the constant velocity and the acceleration due to gravity are perpendicular to each other. Therefore, the velocity u cos theta won't change with time. Okay, so u cos theta multiplied by the total time of flight, that is the range. Total time of flight is how much? It is 2u sine theta by g. Therefore, range is u cos theta multiplied by 2u sine theta by g. So, result is what? U square sine 2 theta by g. U square sine 2 theta by g. So, this is the range r. Now, range r will be maximum when sine 2 theta will be maximum. And what is the maximum value of sine 2 theta? We know maximum value of sine 2 theta is 1. And this maximum value occurs when the angle is 90 degree. That means when 2 theta is 90 degrees, that means when theta is 45 degree. Okay. So, range is maximum when theta is 45 degree. Now, come to our problem, where the stone was thrown from a height. Say, height of the tower was capital H. Capital H was the height of the tower. So, from the top of the tower, the stone was thrown with an initial velocity of u, which makes an angle of theta with the horizontal, etc., etc. Then, the particle ultimately reaches to the ground. So, here, what is the vertical displacement? Here, vertical displacement is minus capital H. That is the vertical displacement. Why minus? Because initially the velocity was in the upward direction and displacement is in the downward direction. Right? Capital H is, what is the direction of capital H? It is in the downward. Therefore, they are opposite to each other. So, we have to write we have to write H with minus sign. Okay. So, writing that thing, instead of small h, you write minus h, and ut, in the right hand side ut is there, again u will be replaced by u sine theta, and plus half gt square will be replaced by minus half gt square. So, this way you will get one quadratic equation in t. You will get one quadratic equation in t, and then you have to solve this equation t. So, you will get value of t in terms of u, g, u means initial velocity, g is acceleration due to gravity, and theta. Theta will be there. So, you will get t in terms of all these things. But here you know that u and g are not the variables, but theta is the variable. Because question was for which angle the range will be maximum. For which angle of projection the range will be maximum. That was the question. So theta is here the variable, u and g are, for the given problem, these are constants. So using solving this quadratic equation, you will get one value of t. Okay, I think you will get two values of t, one negative, one positive. Negative value is not valid for the given problem, so you have to take the positive value. So after getting the expression for t, you put it in the equation for range. Range is equal to u cos theta multiplied by t. So now you put the expression for t here. So range, you have got range as a function of theta. You have got range as a function of theta. Now to calculate maximum range, you take derivative of range with respect to theta, means dr d theta. Dr divided by d theta. You take this derivative. And then after calculation of the derivative, make it equal to 0. Make it equal to 0. This way you will get one value of theta, and that is for the maximum range. Whether it is maximum or minimum, you know how to test it. Take the second order derivative and then you know how to check it. Okay. So just this discussion was about projectile motion. Just one thing you have to note down, that for all the cases, theta need not to be 45 degree for maximum range. For different cases, theta may be different for maximum range. Okay. So here in this problem, you will get maximum value of r. After getting maximum value of theta, you will get r. And if you put capital H is equal to 0 in the expression for r, again you will get u squared sine 2 theta by g. If you put H is equal to 0. And also you will get theta in terms of capital H. You can see the dependence of theta on capital H. For maximum range, you have to do what? You have to make dr d theta equal to 0. This way you will get theta in terms of h. So theta as a function of h, means theta depends upon h. And in that expression, if you put h is equal to 0, capital H is equal to 0, you will get theta again 45 degree. Okay, so this is the end of the problem. Still, if you have any queries, you can write in the comment box. Okay, thank you.